Welcome to Math Mini Lessons. In this lesson, we're going to subtract fractions with regrouping, meaning we don't got enough. And when we don't have enough, we're going to have to regroup. So as I'm modeling, look to see how I create like denominators first, using some type of sum strategy. There are many. I'll show a few. You may have some others. Then how I regroup the minuend, meaning the number we're taking from. If I don't have enough, how do I make enough? How do I make it possible? And then accurately subtract like fractions to find the difference. So let's start off with a little bit of a review using a number line. These are like fractions. And in this case, I have 1 2/3 and 4 1/3. And I want to know the distance between them. And I could represent this as a subtraction problem. 4 1/3 minus 1 2/3. For fractions, especially for subtraction, I like stacking them because it's easy for me to look to see, do I have enough? Now, luckily, these are like fractions, so I don't have to do any work there. But I like to look and say, do I have enough? And I have enough to subtract here, but I do not have enough to subtract here. So what could I do? Now, if fractions are already pretty tough for you, you could use a number line method and just add up to the other number. Because again, I'm looking for the distance between these two. So if I can't subtract down, why not add up? And what I love about this is you can have all kinds of different ways to add up. So for me, an easy way is I can just want to get to 2. So I'm going to add 1/3. And then jump from 2 to 4. So that would be adding 2. And then add another third. And so altogether, I have a distance of 1/3 plus 2 plus 1/3, which is 2 2/3. That is the difference between those two numbers. That's the distance between those two numbers. So that's one really cute method that you can use, is just using a number line. Let's look at this way. And in this case, again, they're like fractions. If I do not have enough, which I do not have here, what I can do is I can take one of my whole numbers and I'm going to add it as a fraction. Now, why am I putting 3 over 3? I can decide whatever that fraction is as long as it's equal to 1. But in this case, I want all the fractions to have the same denominator. And now that I have that, I can rewrite it. And now I can regroup this and rewrite it as 3 4/3 by adding those parts together and subtract 1 2/3. And when I subtract, I can get 2 2/3. Hit pause and jot this down into your notes. What is the value of the expression below? 3 1/4 minus 1 7/8. Obviously, I'm thinking my criteria for success. I have to make them like fractions first, and then I may have to do some regrouping if I don't have enough, and then accurately subtract. Okay, so let's turn these to like fractions. And the good thing is that with 1/4, I know my common denominator can be 8. It's like I know that 8 is just a multiple of 4. And if you're stuck figuring out what to multiply by, 2 times 4 makes 8. So 1 times 2 makes 2. And you're probably doing that part in your head. So let's rewrite this as 3 2/8 minus 1 7/8. All right, I'm going to just erase this part down here. Now you can ask yourself, do I have enough? I like going left to right. I have enough to subtract on the left. I do not have enough to subtract here on the right. So we're going to have to do some regrouping. So I give kids a lot of choice here. You can either use a number line and count up. From here, count up 2, 3 2/8, or you can just subtract with the standard algorithm. I'll show you both and choose the one that makes the most sense for you. So here's 1 7/8. Here's 3 2/8. I'm finding the distance between them. And I find this to be the friendlier way. I like my numbers to be super friendly, meaning I like to add and get them to like whole numbers. So I just want to get this to 2. And I can just add 1/8 to get to 2. And I'll get this to 3. I just have to add 1. And now I just have to add 2/8 to get from 3 to 3 2/8. So now I can add all of these up. 1/8 plus 1 plus 2/8 all together. This is 1 3/8. So super easy way with just counting up. And notice I didn't have to do any borrowing at all. So that's one method that can work for you. If you like the standard algorithm, we'll come right back to it over here. So again, remember I don't have enough here. So when I do not have enough, I'm going to take 1 from here and add it as a fraction. So 8 over 8. Why? Because I want all my denominators the same. Now I can rewrite it. Let's give myself some more room. So now I have 2 and 10 eighths, because that's all this right here. I just don't want to write it here where it's small. Minus 1 and 7 eighths. And I have enough to subtract now. 10 minus 7 is 3 eighths, 3 eighths, and 2 minus 1 is 1. 1 and 3 eighths. Easy peasy. Very, I hope this is nice and easy enough to follow. Let's hit pause and jot this down into your notes. And again, there is no judgment. If you need to start with the number line first, use that. But eventually, it is helpful to get to the regrouping stage to be able to subtract larger values. Okay, let's do one more together. And now I have 9 and 2/3 and 4 and 4/5. So again, I want them to have the same denominators. So I'm going to make them 15ths to make it easier. And I like to stack. I love stacking numbers. So 9 and 2/3. I want this to be 15ths. And 4 and 4/5. Again, I want this to be 15ths. All right, 3 times 5 makes 15, so 2 times 5 is 10. And 3 times 5 is 15, and 4 times 3 is 12. Okay, so now we can rewrite this as 9 and 10 over 15 minus 4 and 12 over 15. And as expected, we don't got enough. I can see it very clearly. I cannot do 10 minus 12, so we're going to have to do some regrouping. So let's do that. We're going to take 1 from here. And we know this is going to be 15 over 15, so all the denominators are the same. And now we'll be able to subtract. So let's put, making my work pretty linear, so I can go down to the next part. 8 and 25/15 minus 4 and 12/15. So I can subtract pretty easily now. 25 minus 12 is 13 over 15, and 8 minus 4 is 4. So I have my answer, D. And that's it, Math Marvels. I hope this was really helpful. You can see that we're just taking it one chunk at a time. A lot of 5th graders get really anxious when they see this problem. But again, just go part by part. Start by just making them like denominators, which we know how to do. And then you're going to take the next chunk, which is just ask, do I have enough? And if you don't, you're just taking 1 and turning that 1 into a fraction by cutting it into those pieces. And you want your fraction, your denominators to all be the same. And then just subtract. So some things that I know there are other methods people like to do that I just want to name. I know some kids really like to just change it to the whole thing to an improper fraction. So for example, I've seen some kids, and I'm not knocking this method, but I'm just going to give my 2 cents of why it may not be as helpful. So for example, if you have 9 and 10/15 minus 4 and 12/15, you can change these to improper fractions. It just means I'd have to multiply these numbers and add the other ones, and that's just a lot more work. So it's not that this method is incorrect, it's just going to take me more work to multiply here and then add 10 and then do the same thing on the bottom and add 12 and then subtract and then change it back to a mixed number. So that's why I don't show that method, although it is a valid method. If it works for you, go ahead and use it. And the other method I see some kids using, and because they like to use it, and they